sick. So let's get to this. This is what you had to do in class. You have 3 equations, right? So 3n squared, n squared plus 4, n squared minus 1. So each of these represents one of these patterns, right? So you just gotta figure out which one. Well, if you notice the first one here, these corners always repeat. So if I were to draw the next shape, I would have 1, 2, 3, 4, and then a square inside, and again the next shape would have those 4. So it'd be always something, right? Square in the middle plus 4, square in the middle plus 4, and right off the bat we know that it should be this one, right? So that's kind of obvious. All right, so that's the nth term for that one, right? So this one is gone. So now this one, 3n squared. Well, another thing you can do is just plug it in, right? So let's say this one, y equals 3n squared. Let me put it over here, right? Y representing the total number of squares. So let's plug in 2, the number 2, the second term, which is n, right? So if I plug in 2 in here, I should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I get 12, that means this equation represents this pattern. Well, let's try it. Y equals 3 times 2 squared, right? So the second term is telling. So the first term is 3. The second term is 1, 2, 3, 4, 5, 6. 6 times 2 is 12. The third term is 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 9 is 27, right? So if I plug in 2, I should get 12. Do I get 12? Look at that, I do get 12. So this one, pattern C, is represented by this particular equation. All right, so let me take that out. And obviously the last one, this pattern is that one. And you can sort of tell, right, I mean, if you think about n squared, what are the first 3 terms? It's 1, 4, 9, and this one is 1 squared minus 1, which is 0. This is 2 squared minus 1, which is 3, and this would be 3 squared minus 1, which is 9. So there's one less than 1, 4, 9, right? So the next pattern, the next one here would be 15. It'd be a 4 by 4 square. Right? If you think about it, it'd be a 4 by 4, 1, 2, 3, 4, right? But we would have this guy in the corner missing. Right, so it'd be a 4 by 4 minus the one in the corner. So instead of 16, it would be 15. Right, so it's the n squared minus 1. So that's question 1. Question 2, well, question 1. One of these patterns has 432 tiles in it. One of these patterns has a step with 432 tiles in it. One has a step with 195 in it, and one of these patterns has a step with 404 tiles. So if you continue, so let's take number 1 here. Let's do number 1. If you continued with number 1, step 4, or 4th term, 5th term, 6th term, and you go so on and on, eventually you would hit one that has 432 or 195 or 404. You just got to figure out which one it is. Alright, so let's work, actually, you know what, let's do this one, pattern B, and see which of these 3, right, so 4th term, 5th term, 6th term, 7th term, etc., right? One of these terms, would 432 fall in here, or would 195, or would 404, right? We just don't know. So let's plug it in. So this is saying, and I'll use that equation that, let's try 432. 432 is the total number of tiles, and n squared minus 1. If you do plus 1 on both sides, right? Let's do plus 1, plus 1. N squared is 433. Now, if you think about it for a second, right? Remember, you take the square root of here, we take the square root of here, and n equals the square root of 433, which is plus or minus, well, it's not a perfect square, it's 20.80. So obviously, this is not it. Right, because it's telling you that at a step, at the term 20.80, we would have 433 squares. Well, obviously you can't have step 20.80, right? You want to have a full step, so that's not it. Let's try 195. So when there's 195 tiles, what step was it? Well, n squared minus 1. We do plus 1, we get 196. Oops, sorry. Plus 1, right? This goes away. N squared is 196. Is there square root of 196? Well, it is 14. Look at that. So n equals 14. So they're saying that what we just found out is that the 14th term, it would have 195 tiles. Right, and that number works with this equation. Right, when n equals 14, the 14th term, we would have 195 tiles, and that works. So 195 belongs to pattern B. Oops, sorry. So we found out that 195, so the 14th term, you would have 195 squares or tiles. Okay, so that belongs to this pattern here. So that's gone. Let's try 432 with the first one. So let me just write this again over here. Y equals n squared plus 4. So when there's 432, right, what term was it? When there's 432 tiles in this pattern, right, what term was it? Was it the 5th term, the 6th term? Well, let's find out. So we do n squared plus 4, right? So y is what, 432. So I'm going to subtract 4 on both sides. And I get n squared equals 428. Now if you take the square root of both sides, right, this goes away, 2 here. And 428 square root is not a perfect square, right? It's 20.68. So this is saying that when the term on pattern A, when the term was 20.6, you would have 432 tiles. Well, obviously that's not going to work. So let's try 404. Right, so that 432 doesn't work for here. So let's try when y is 404. So in pattern 1, pattern A, when if there's 404 tiles, what pattern was it? Sorry, what term was it? So plus 4, so we're going to subtract 4 on this side, subtract 4 on this side. N squared is 400. And that one works. And we'll take the square root of this side, take the square root of this side. That goes away. So what's square root of 400? N equals, it's actually plus or minus 20, right? But we're not interested in the negative, so n equals 20. So that actually works. So this is saying that in pattern A, the 20th term, if you were to continue this pattern, pattern A, the 20th term, let me just take this. In pattern A, the 20th terms, you would have 400 tiles. Okay, so obviously the last one so that one is gone. So this last one, 3n squared, is 432. So let's just see if it works. So in this one, it's saying that if you continue this pattern, there is a term here where you would have 432 tiles. We need to find the term, right? What term would that be? Well, 432 equals 3n squared. We're going to divide both sides by 3. 432 divided by 3 is 144, right? N squared. And again, take the square root of both sides. This makes this goes away. So I'm left with n equals the square root of 144, which is plus or minus 12, or just 12 for us. So this is saying that if you continue pattern C, the first term, the second term, the third, and you went on, and you got to the 12th term, it would have 432 tiles. Okay? And that would be the word for A, B, and C. Alright, so the rest is pretty self-explanatory, but you know, this one is asking us for the 8th term in this sequence. So instead of n, I'm going to plug in 8 in here and plug in 8 in here, right? So we're going to get 2 times 8 squared plus 3 times 8 minus 2. Well, let's follow the order of operations, please. 8 squared is 64. So we're going to get 2 times 64 plus 3 times 8, which is 24 minus 2. 2 times 64 is 128 plus 24 minus 2. We're going to get 152 minus 2. Final answer, 150. So in the 8th terms of this sequence, you would have 150. That would be the number, 150. You find an expression in terms of n for the nth term. So this one, again, we have to find do the first difference, second difference, and that's what we're doing right now. So let's do that. All right, so again, first, it's 1, 2 to 3 is 1, 3 to 6 is 3, 5, 7. So we have to take the second difference, so that was 2, 2, 2. So we know it's quadratic, so n squared, we're going to half of 2, which is 1. I'm going to put the 1 in here. So my expression already has 1n squared, right? So what does a 1n squared sequence look like? It's 1, 4, 9, 16, 25. We're going to subtract 2 minus 1 is 1. 3 minus 4 is negative 1. 6 minus 9 is negative 3. 11 minus 16 is negative 5, and 18 minus 25 is negative 7. So we have another sequence in here. So let's find. So 1 to negative 1 is minus 2, minus 2, minus 2, minus 2. All right, so that tells us there is a linear sequence in there, and negative 2 is our coefficient. So what does a negative 2n sequence it looks like? So let's plug in 1, 2, 3, 4, 5. The first 5 numbers would be negative 2, negative 4, negative 6, negative 8, negative 10. I'm going to subtract 1 minus negative 2 is 3. Negative 1 minus negative 4 is 3. And you're going to get negative 5. Negative 3 minus negative 6 is positive 3, so this is 3, 3. So our final answer is 1n squared, or better yet, just n squared minus 2n plus 3. Let me get some room over here. 3, 10, 19, 30, 43. Take the first difference. This is 7. This is 9. This is 11. This is 13. Second difference is 4. This is, sorry, not 4, 2. This is 2, and this is 2. So again, so we know it's quadratic because we took 2 differences, and our coefficient is going to be 1. Yeah. So what do I do now? I plug in 1, 2, 3, 4, 5, the first 5 numbers in this sequence. Right, it would be 1 squared times 1, or 2 squared. So it's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. We're going to subtract, right, our original, and this one. So be careful when you subtract. 3 minus 1 is 2, 10 minus 4 is 6, 19 minus 9 is 10, 14, 18. All right, so now we start all over. Notice that there's a sequence here that goes by 4, 4, 4. So this is 4, this is 4, this is 4, this is 4. Right, so it's a sequence that goes by 4. So we here's my n, and that's my coefficient. So we know it's a sequence that goes by 4. And what does a sequence that goes by 4 look like? Well, the first term in a sequence that goes by 4 is 4. The second is 8, 12, and 16, and 20. So here's my answer so far. So my expression is n squared, which is this guy, and this, plus 4n. Now we gotta subtract. Do I have to make any adjustments? Because a 4n sequence goes by 4, 8, 12, 16, 20, but I don't really want 4, 8, 16, 20. I want 2, 6, 10. So what do I do to this to actually get 2, 6, 10, 14? Well, 2 minus 4 is negative 2. 6 minus 8 is negative 2. So let me put this in parentheses here. 10 minus 12 is negative 2, negative 2, and then negative 2. So think about it. For 4 to become 2, I subtract 2. For 8 to become 6, I subtract 2. For 12 to become 10, I subtract 2. So this is my final answer. Final expression, and again, same thing. So again, guys, this is over and over the same thing. Just more practice. 4, 2, something wrong here. Something wrong with F. 610, did I copy this incorrectly? Oh, I gotta find it. Alright, I'll see if I can come back and switch F. Alright, I'll stop this. I'll make 2 videos. No.